Students, this is another problem from current electricity and it is also an asked problem in CBSE boards and it is equally important for the engineering students also. So use Kirchhoff's rules to calculate the current in the arm AC of the circuit. We have to evaluate the current that is flowing in this arm AC. Okay, so first thing that we have to do is assume the current in this branch. Okay, this is the positive terminal of the battery and as I suggested that assume direction of current from positive terminal of battery and this is our assumed current in AC branch from C to A. We assume this as, so assume current, suppose it is from C to A. Now we have to find the magnitude of this current. As we have given here, one current I1 is flowing here. Yes, the thing that you have to understand that if any current is mentioned, then this current will be continued till the next junction. Junction is the point where we get a division. जब तक आपको कोई डिवीजन नहीं मिलता तब तक आपका करंट वैल्यू सेम रहेगी. So this I1 current would be flowing here in this 30 ohm. I2 current is flowing in this branch. Now what is the amount of current in terms of I1 and I2? This I1 current is moving in this direction, okay, as it is given, and this current is given the direction like this, so it would be like this. So both of these currents are flowing through this resistor in the same direction. Here our current through this CA branch is nothing but summation of I1 plus I2. To find the values of these current, apply KVL in these loops. So apply KVL in loop 1 first. Start from any of the point of the loop, moving around the loop and coming back to the starting point is the application of KVL. Okay, so here across 30 ohm there is a voltage drop. So take the sign as minus 30 I1. Okay, in the direction of current take the sign as minus. Now we are moving here and the last battery terminal is plus, so take the sign as plus 40. Okay, here in this resistance we are again moving in the direction of current, I current, so minus will come, minus 40I will come is equals to 0. So our equation is 3I1 plus 4I is equals to 4. This is our first equation. We got by applying KVL in loop 1. Now apply the KVL in this second loop or in this outer loop. So here I am applying KVL in this second loop to get the another equation. Start from this point A, moving around this loop path and coming back to the starting point and consider all the voltage drops in the path. First here current is moving in this direction and we are moving opposite to that, so take this sign as minus. We are moving opposite to current, so take the sign as plus. It is 40I. This sign that comes in the last in our path, that is minus 40. Here we are moving opposite to current, take sign as plus. Here the last terminal of battery in our path is minus, so again minus 60. Now we return to our starting point is equals to 0. So simplify these. 4i, so write down 4i here, and 2i2 is equals to 10. This is our second equation. In our equation, there are three variables, I, I1 and I2. So replace this I2 by I minus I1 in the second equation. So it is 2I minus I1. So our equation will become 2I plus 4I, that is 6I and minus 2I1. Okay. Now we will solve these two equations to find the value of I. To find the value of I, we have to eliminate this I1. So multiply this with 2 and this with 3, and adding them will give us the value of this. So these two will be cancelled. Here 8i plus 18i is equals to 8 plus 30. Okay, so here 26i is equals to 38. So our I comes 19 by 13. So our I is 19 by 13 ampere, and the direction we assumed is correct since we got positive sign here. So it is from C to A. So from C to A, 19 by 13 ampere current is flowing. It is our desired value of the current in the center AC branch. थैंक यू. अगर आपको वीडियो अच्छा लगा हो तो इसे प्लीज लाइक और सब्सक्राइब करिए.